Hello and welcome to EE333. I'm your instructor, Gregory Myers. In this video, we're going to take our first look at how to create a class that we are ultimately going to create instances of objects from. Now, in this video, we're going to work just simply on the setup and the structure of the class. And then in subsequent videos, we're going to continue to work with this class and then ultimately leverage it for things like file input and output. So to begin with, what we want to do is we want to go to our source packages, and we simply want to add a new Java class. We want to make sure that it ends up in the same package as our fundamentals driver.java. And for the class name, we simply want to call it user. Our attempt here with this user class is simply to model or describe a user of a system. All right, so to begin with, we can clean up the template that NetBeans has provided. You'll notice that it is already pre-populated. Some of the structure, in this case, our public class user, is the syntax that we use to identify a new class. And if you also notice, we have a file called user.java under the EE333 packages. So far, so good. Well, what we want to do with this class is we want to use it as an attempt to model the user of a system. And what that system is doesn't really matter too much right now, but effectively what we want to do is we want to capture information about the user and use this as a container to hold that information. Likewise, we also want to identify things that the user can do. So I'm sort of just jumping straight into this without a formal definition of what an object or a class is, and I'm doing that intentionally because I want us really to focus on the ability to model the real world. And so first thing that should come to my mind, or come to your mind rather, is how would we describe a user of any system, whether it's a user of a registration system, the user of a shipping system, the user of, let's say, a gym membership system, etc. The idea is that there's going to be certain pieces of information that we want to store about the user, and then there are going to be things that we want to do to the user or that the user can do. This is the significant difference between objects and classes and what you would have seen before in structures in C. The structure essentially is nothing more than a container of data. Now you can get fancy with it, but underneath it's essentially nothing more than a container of data. A class is going to be a template for an object. So a class, if you would, essentially is a way of describing what an object properties, what properties an object has, as well as what an object can do. An object is a particular instance of that class. So for instance, if we use this user as an example, there will be a user class, and then there will be instances of that user. So essentially, the user should provide things like a place to store the first name, a place to store the last name, and so on. And then each individual user or each instance of the user class will have a specific first name, a specific last name, and so on. So what we're going to do is we're just going to jump straight into creating this user. The last thing that I want to point out before we get started is the public in front of the class. And this just simply means that anything in the E333 package can see and can call anything, can see and can call or create instances of this user class. So the first thing that we want to do is we want to come up with a way to create an instance of a user. Well, the syntax for that is pretty straightforward. You just have a public method, and we're going to start off with a public method that just simply accepts no input arguments. So we have public user and then closed curly braces. So this right here creates an instance of the user accepting no input arguments. We'll come back to that in just a second. The next thing that we want to do is we want to start thinking about how to describe the user. Well, a user, as we mentioned earlier, should have things like a first name, a last name, an ID, and then just to change it up a little bit, we're also going to include the age, so that we have both a string and integer values. So what we need is we need a set of variables that are going to be associated with the user to hold this information. But what we're going to use is a different keyword, different scope. Now we're going to have each one of these variables be private. So we're going to start off with a private string, and we're going to start off with an ID. And the intention is this should be unique. We're going to have private string first name. Notice the capitalization. Private string last name. Once again, notice the caps or the capitalization. And then lastly, private int age. Now, the idea here is that we want to be able to store this information, but we need to have a way then to be able to get it into a particular instance of a user, because remember right now, this is a template, this is a cookie cutter. And so to begin with, when we create an instance of a user accepting no input arguments, this means that we have no way of getting information in to the user when we create the user. So no information accepted when it is constructed. Therefore, we need to be able to do this later. And just like with any other variable, we will need to initialize the private variables so as not to cause errors. And what this simply means is that we go through and we declare, we go through and initialize each one of the variables that we have declared. And to do that, we can do this a couple of different ways. We can simply say ID. If you notice that it is highlighted now, the private string ID, the ID is equal to a new, and we can simply specify a new string. Now, one thing that I would encourage you to do is to go ahead and navigate and go to source, and you'll see where the string function and the string class reside. And so if you take a look here, this gives you all of the information about where the string class resides. I'd also encourage you to take a second to pull up the help in the Java documentation so that you can see a little bit more information about a string and how to go about constructing it. It turns out there is actually a couple of different ways that we can go about creating strings, but we are going to focus on the more object-oriented approach of declaring a new string. Now, note here that the java.lang, or rather the string, resides in java.lang.string. So for these first few examples, what I'd like for us to do is to depart just a little bit from some of the textbooks, and I would like for us to explicitly state the full package path to our object. So in this case, a ID is going to be equal to new java.lang.string. Our first name is going to be equal to new java.lang.string. And our last name is going to be equal to new java.lang.string. Conversely, one of the things that we could have also done is we could have simply said ID equal to a set of empty quotes. But once again, with strings, I'd like for us to get familiar or get comfortable with the idea of them being objects. Now, what is this in contrast to? Well, this is in contrast to the integer that we have listed above, and that is our age. And our age is actually a primitive. And so in this case, what we can do is we can just assign a value, in this case of 0. The last thing that I would like for us to go ahead and get into a habit of doing, although it is not completely necessary as you see, is I would like for us to specify explicitly which class these properties or these variables are related to, and specifically which object of this class, rather an object of this class. And what do I mean by that? Well, in this case, the ID, it's a little bit confusing because the ID appears to belong to the class, when in fact, the ID will belong to an instance of a class. So to accomplish this, we can simply say this.id is equal to new java.lang.string. This dot first name is equal to new java.lang.string. And then this dot last name, as well as this dot age. And using the keyword this means that it belongs to a specific instance of the class. Once again, it's not necessary, but it's helping to reinforce this idea of instances versus class. And we'll talk more about this as we go along in the semester. And we'll come back to some of the warnings that we're getting here as far as the IDs being, in this case, it's saying the field ID can be final. We'll come back to things like this. But so far, all we've accomplished is we've identified a few properties or a few fields or parameters associated with the user, and then we have the ability to create a new user, but we have no ability to change any of the properties associated with that user. And we can do this, or we would want to do this, one of two ways. We can either create an instance of a user accepting no input arguments. We can also create an instance of a user accepting some input arguments. And this is where you can decide what are the most important arguments. So my argument would be that probably the ID is the most essential. You could argue that perhaps you have to have the ID, the first and the last name, but you don't likely need to have the age, at least immediately. And so what we can do is we can have another method called public user. And at this point, what we can do is we can simply identify arguments that we wish to pass. In this case, we want to pass a string ID, a string first name, string last name, but no age. And so now, if you notice here, we can accept multiple input arguments And if you also notice, we can have multiple functions with the same function name. This is also something that we've not seen before in C. Now, as I mentioned before, at least temporarily, I would like for us to get into the habit of using the full package path. And in this case, it's going to be the java.lang.string. I just want us to get familiar with the framework. And then later on, as we're more comfortable with Java, we can utilize the imports. Now, the need for the this that we used earlier should become more apparent. We can then say this.id is equal to the ID that was simply passed to us. We can also say this.firstName is equal to first name. And this.lastName is equal to last name. But since we are not provided an age, we simply initialize this to 0. So I'm going to put a little note here, not provided initially, must be set later. Well, when is later? Well, later can be now. In other words, we want to think about how would we go about setting the age, as well as what happens if someone's name changes. Maybe they get married, for instance. So we might want them to be able to change their last name and quite possibly their first name, but we probably don't want them to change their ID. And so what we would like to do now is we would like to add some methods or functions that allow for the user to make some of these changes. And there are a couple of ways to go about doing this. To begin with, what we're going to do is we're going to focus on the manual way of going about doing this. And that is by simply creating some methods that allow for us to make these changes. And we'll begin with the first name. So we'll have a public function because we want other users or other programmers, developers of our system to be able to make these changes to our objects. So we want this to be public right now. So we want to have a public, and what we'll do is we'll make this function, at least for right now, we'll make it void. We'll come back and have this discussion in a little bit, and we'll have a public void set first name. And this public void set first name must accept a string, in this case, java.lang.string of first name. And now inside this function, all this does is it allows for us to say this.firstName is equal to first name. And what this does is this allows for us to change the first name later in the execution of our code. In other words, it doesn't have to necessarily be right at the beginning. It just allows for us to change it later. The second function that we would like to write is going to be a way of retrieving the first name. And we also make this public. We make the return type here, java.lang.string, and we call this one get first name. And the whole purpose of get first name is simply to retrieve or return this dot first name. Pretty straightforward. Now, why do we need this? Well, this is now where it should become apparent what the purpose of the public and private keywords are. Specifically, you'll notice that we have a string ID that is private. The first name is private, and the last name is private. That means the only thing that knows about these values is the user itself. It has no way of publishing that or giving that information out. You can sort of think of this a little bit like the contents of your home. Your neighbors don't explicitly know what is inside your home unless you show them something about your home. And so in this case, we want the user to be able to control what is shown about it. So in other words, if we want to show the first name, we need to create a public function that returns the first name. So continuing on with this theme, we can do the same thing now with our last name. So we have public void set last name and java.lang.string. Whoops. Sorry about that. Got a little carried away there. There we go. Public java.lang.string and last name. And now, just like before, this dot last name is equal to last name. And then we also want to have a getter, which allows for us to retrieve that value. So java.lang.string get last name. Once again, that does not expect or accept any input arguments, although you can have getters that do. So we'll return this dot last name. Trying to keep consistent on my spacing here as best as possible. As we said earlier, the spacing is mainly so that it's easier to see in these videos. And then we might as well go ahead and continue on with our age. So we have public void set age int age, and then this dot age is equal to age. And then additionally, we have public, in this case, int get age, no input argument, and this just simply returns our age, this dot age. All right, so far so good, but you should have noticed that we have yet to deal with one particular property. And I saved that one till last, even though it was our most important one. We want to think about what we will and will not allow, meaning that do we want the ability to change the ID after we've created the user? And the answer is probably not. So this should be unique and cannot be changed. Well, how do we make that happen? Well, the answer is we have a getter but no setter, meaning that once the object is created, there is no ability to change the ID. And by simply forgetting, if you would, or not writing a set function, we prevent that from happening, at least externally or intentionally. In other words, someone can't make a call to it. We can still do things behind the scenes internally, but we'll see how to do that later. So in this case, what we want to have is no setter, but we only want to have a public java.lang.string get ID. And this just simply returns this dot ID. Well, that brings us to a very interesting dilemma. How do we ever set the ID? Well, if you recall, when we first started this out, I just simply built this public user and said that it created an instance of a user accepting no input arguments and just asked that you accept it blindly. Well, there's a couple of ways that we can handle this. So the one approach would be that instead of creating a new java.lang.string, we create the unique ID here. And we'll come back to that. Basically, if you think about it, if you've ever created an account on a website and they suggested to you a username because the one that you wanted was already taken, we can do the same. And in the later video, I'll actually show you how to do that. The second approach would be that we simply come along here and we say public user, and then we have a third constructor. And in this case, that constructor requires a java.lang.string, and it simply requires an ID. And in this case, we simply say this.id is equal to ID, this.firstname is equal to an empty string, or as we saw earlier, we can do new java.lang.string, and we'll use that constructor. And this.lastname is equal to new java.lang.string. And then lastly, this.age is equal to 0. So for right now, what I'm going to do is I'm simply going to comment this out. And the reason is because technically we've got us in a situation where we can call our user constructor without providing an ID and have no way to change it later. We'll revisit this in another video and I'll show you how to create your unique ID. But for right now, what I'd like for us to do is to just go ahead and comment out our constructor that accepts no arguments. So effectively what we have here now is a user class that requires an ID. We would want to do some additional error checking here. So we would want to do additional error checking here. Okay, and an example of that would just simply be to see that the ID.length is in fact greater than 0 or some minimum value that we would want. And the same is true for this constructor that accepts multiple input arguments. And so we might also want to check to see if our first name and our last name are greater than 0, and so on. So there's a lot that we can do here, but we're just now getting started. So we want to go ahead and build this real quick. If you notice that NetBeans automatically saved both of our .java files. And at this point, then we haven't really accomplished anything other than set up our first class. Most importantly, you'll notice that this first class is outside of our fundamentals driver.java. Now, before we go, I want to simply show you how you will access this. So if we come in here and we say EE333 dot, you'll notice that in addition to the fundamentals driver, we now have a user. And so we're set to go. The only other thing that I want to go ahead and take a second to do is back here in our user.java, I would like to add one more function, one more method. And we usually do this at the beginning of every time when we create a class, if we plan on displaying the properties of that class. And so the function that we always want to have is going to be a public java.lang.string, and we call the function toString. And this is simply used to print out, or rather, it doesn't actually, we don't want it to print out. What we want it to do is actually convert the object information into a string. And we're actually going to do a couple of different examples of this, but that's going to be the first method then that we're going to pick up with in our next video. So to begin with, then we'll just leave this one here. But to begin with, though, we always want to include a toString. And for right now, what we're going to do is we're simply going to put in there return, and we'll just put in there, how about TBD? In other words, we need to work on this, or you can put a to do. All right, so hopefully you found this video useful. Like I said, this is meant to be a jumping off point. We've got plenty of things to add here. As always, if you've got any questions or comments, don't hesitate to email me, and thank you for watching.